In the previous video, I introduced these two circuits, a series circuit with two light bulbs and a parallel circuit with two light bulbs, and I asked you to consider that the power being I times V for any individual circuit would produce a certain amount of brightness, and the question was which one would produce more brightness. If you consider the total resistance in a series circuit here, so in the series on the left-hand side, the Req, or the equivalent resistance, is R1 plus R2, which is simply 2R. In the parallel combination, the equivalent resistance is calculated by 1 over the Req, and so we have 1 over R plus 1 over R, which yields 2 over R as a solution to these, but in order to calculate the Req, we need to take the inverse, and so we find that the equivalent resistance is the resistance divided by 2. So on the left-hand circuit, the resistance is 2R, and on the right-hand circuit, the resistance is R divided by 2, or half. So, keeping in mind that P is I times V, I for either circuit can be calculated by the voltage divided by the equivalent resistance, Req. And so we basically simplified each one of these circuits into a circuit that simply has the potential and a resistor that we are identifying as Req connected, and that's it. We're able to simplify both of these through that combination. And so looking at this, we know that the current for this circuit is going to be drastically less than the current for this circuit due to the fact that the resistance is twice as high as it is for one resistor and 4 times as high as it is for the parallel component. And so when I take the I and multiply times the voltage, which is the same in both cases, I times V, this circuit, the parallel circuit, creates a much brighter overall output.